Elon Musk has unveiled ambitious goals for Tesla's Optimus robots, aiming to produce thousands this year. The production is set to scale significantly, with targets of 50,000 units in 2026 and an astonishing 1 million units by 2027. However, an unexpected development occurred in late July. Tesla announced that a substantial number of Optimus bots had already been manufactured, but not for sale. For now, they're being used internally. These robots showcase a brand new design that is yet to be revealed to the public. Notably, Tesla has increased production to an impressive 5,000 units per month. The first commercially available bots are expected to be priced at $10,990. This raises a major question. What will the third-generation Tesla bot look like? Before we begin, please help us reach 15,000 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Optimus and the latest news. Elon Musk recently shared major developments regarding the upcoming Tesla bot version 3, emphasizing a complete redesign that marks a clear departure from the current 2.5 version. But that's only the start. According to Musk, Gen 3 will include a substantial increase in degrees of freedom, a critical advancement in humanoid robotics. This enhancement will significantly improve the robot's human-like motion and capabilities, making it far more versatile and lifelike in real-world scenarios. Currently, Tesla is already manufacturing Optimus bots for internal operations. However, Musk hinted during Tesla's Q2 earnings call that the consumer-ready version could look drastically different from what's been seen so far. When Optimus first debuted during Tesla's 2021 AI Day, it was merely a stationary model, alongside an actor in a robot costume dancing awkwardly on stage. That early version was more concept than reality. Since then, Tesla has made continuous strides in robotic development, leading to more sophisticated iterations like Gen 2 and Gen 2.5, which are now being built at scale. At Tesla's all-hands meeting in Q1 2025, Musk informed employees that the goal is to manufacture the first real army of Optimus robots by the end of the year, a bold step toward wide-scale deployment.
So this year, we hopefully will be able to make about 5,000 Optimus robots. We're aiming for enough parts to make 10,000, maybe 12,000. But since it's a totally new product with totally new, like everything is totally new, I'll say like we're succeeding if we get to half of the 10th.
Initially, most observers believed Tesla would stick with mass-producing Optimus Gen 2.5, possibly adding enhancements like hands with 22 degrees of freedom. That assumption was reasonable. After all, Gen 2 had already demonstrated smooth, capable movement and a sleek, polished design that outclassed many rival humanoid robots. However, Tesla's Q2 2025 earnings call brought a decisive update from Elon Musk. The version that will enter large-scale production is not Gen 2.5, but the fully redesigned Optimus version 3. In other words, the first customer-ready Optimus units won't resemble the Gen 2.5 bots Tesla has been internally deploying since 2023. Instead, they'll represent an entirely new evolution of the platform. Musk expressed strong confidence in the Gen 3 model, describing its design as elegant and reaffirming his bold forecast that Optimus may ultimately become Tesla's most significant product to date. Elon Musk described the Optimus version 3 as elegant, noting that every aspect of its design is grounded in fundamental physics. Unlike its predecessor, V3.5, Gen 3 has undergone a near-total overhaul in both form and function. According to leaks and previous confirmations from Musk, the new model will feature a front-facing digital screen and integration with Grok Voice AI. This display will communicate real-time status updates and allow users to access information directly, essentially turning the robot's face into a built-in smart interface. Tesla is also focused on making the bot's frame lighter to help it achieve the targeted walking speed of 5 miles per hour. It's still unclear how this will be accomplished, though it could involve switching to lighter materials or improving the robot's joint design. Musk teased that the new version will be extraordinary and is likely to be revealed later this year. If predictions hold true, Optimus Gen 3 may be unveiled during the Tesla shareholder meeting in November 2025. a venue Musk has hinted could include live appearances by working Optimus units. Currently, Optimus version 2.5 can perform around 1,500 basic tasks, but with Gen 3's enhanced range of motion and precision, thanks to more degrees of freedom, that number could double to 3,000 or more. For instance, while Gen 2.5 might carefully hold an egg, Gen 3 could potentially crack, cook, and serve it, showcasing a significant leap in capability. Despite the enthusiasm, Musk acknowledged the complexity behind building Gen 3, calling it an insanely hard problem. None of the robot's components are off the shelf. Everything, from motors and sensors to gearboxes and electronics, has been custom engineered by Tesla to suit the unique requirements of humanoid robotics. He also emphasized that Optimus, much like Tesla's self-driving cars, is trained using neural networks. This approach teaches the robot how to move and respond by interpreting inputs from its limbs and sensors, just as Tesla's full self-driving system learns from real-world driving scenarios. On the hardware front, Tesla is doubling down. The company recently finalized a $16.5 billion deal with Samsung Electronics to produce its next-generation AI-6 chips, a vital component for both Optimus and Tesla's autonomous vehicle platforms. These custom chips will be manufactured at Samsung's Advanced Semiconductor facility in Taylor, Texas. The multi-year contract, confirmed by Musk and backed by Samsung's regulatory filings, runs through December 31, 2033, and is expected to support the production of at least 5,000 Gen 3 units in 2025. This collaboration underscores Tesla's long-term vision, using custom silicon and real-time AI processing as the foundation for its robotics and self-driving systems. How Tesla Optimus become the best homemaker. Tesla's Optimus version 2.5 can currently handle about 1,500 basic tasks, but version 3 is expected to potentially double that number due to its expanded capabilities. The increased degrees of freedom make it more precise and versatile, so reaching 3,500 tasks is entirely feasible. However, Elon Musk has acknowledged that developing Tesla Bot version 3 is a formidable challenge. Every component, from motors and gearboxes to sensors and power electronics, must be custom-built by Tesla, as no off-the-shelf parts meet the robot's advanced requirements. A recent 44-second video by Figure's CEO Brett Adcock showed the Figure 02 robot picking up laundry items and placing them in a washing machine, repeating the action 9 times in under a minute. Yet, it stopped short of adding detergent or starting the machine, indicating limitations in completing the full laundry process. In contrast, Tesla's Optimus was showcased dancing across a factory floor, performing spins, slides, and rapid movements with flawless balance, unsupported by wires or visual effects, as confirmed by lead engineer Milan Kovac. While Figure 02 excels in delicate hand movements such as handling soft fabrics, Optimus outshines it in full-body mobility, speed, and stability. With Optimus's newly upgraded 22-joint hand, mastering tasks like handling soft items is only a matter of time. Musk emphasized the complexity of the project, noting that every part is designed from first principles, including motors, sensors, and control electronics. Tesla is leveraging neural networks, similar to those used in its self-driving cars, to train Optimus's limbs and sensors. Musk likened Optimus to Tesla's electric vehicles, describing both as robots optimized with the same AI techniques. Musk also shared ambitious plans to scale Optimus production, targeting up to 100,000 units per month by 2030, a goal he believes is achievable but challenging. He admitted that the initial 1 to 2 years will be tough, with potential supply chain issues or technical setbacks, especially as new features are added to version 3. These challenges align with Tesla's history of production scaling difficulties. Significant work remains to push Optimus 3 forward, requiring a higher level of engineering sophistication. Initially, Optimus was thought to be limited to Tesla's automotive factories, but Musk clarified on X that a limited batch of humanoid robots will be deployed in-house starting in 2025, with over 1,000 or even several thousand units expected to operate within Tesla next year. The future of manufacturing is increasingly robotic, and automation is becoming essential for sustainable industry. Tesla's gigafactories already use robotic arms, gigapress machines, and automated paint lines, but these are fixed and task-specific. Optimus represents a shift toward adaptable, intelligent, and mobile automation, aligning with Musk's vision of a machine that builds machines. Tesla is openly pursuing this goal, aiming to revolutionize general-purpose automation. What changes will Tesla Optimus make to beat all rivals? Tesla Optimus Gen 3 has achieved a groundbreaking 99.7% accuracy in performing over 1,200 sophisticated tasks in dynamic real-world settings, setting a new standard for humanoid robotics. This leap forward raises the question, how does Optimus Gen 3 compare to cutting-edge competitors like Unitree's G1 humanoid robot? And what drives its superior performance? The answer lies in Tesla's revolutionary integration of lightweight hardware, a next-level AI core, and an innovative training paradigm that outpaces traditional approaches, positioning Optimus as a leader in precision and adaptability. Starting with hardware, Optimus Gen 3 boasts a redesigned frame weighing just 99 pounds, a significant reduction from the 132 to 220 pounds typical of other humanoid robots, including Unitree's G1, which weighs approximately 120 pounds. Constructed from a titanium-aluminum alloy, Optimus's chassis balances strength and agility, reducing inertia by 35% compared to Gen 2, enabling precise movements for tasks like threading a needle or sorting microcomponents. In contrast, Unitree G1, while agile with 43 degrees of freedom, relies on a heavier steel-based frame, limiting its finesse in ultra-delicate operations, with a reported positional accuracy of 2 to 3 millimeters versus Optimus's 0.5 millimeters. The heart of Optimus Gen 3's 99.7% accuracy is its AI-driven perception system, powered by Tesla's Dojo V3 chip, processing 2 billion high-resolution video frames per second from 8 advanced cameras. This enables real-time 3D spatial analysis with a 0.05% error rate, far surpassing Unitree G1's vision system, which uses 6 cameras and achieves 92% accuracy in controlled settings. Whether arranging delicate glassware or navigating a crowded warehouse, Optimus maintains a positional deviation of just 0.6 to 1 millimeter, ensuring flawless execution. Unitree G1, while capable of tasks like climbing stairs, struggles with complex object manipulation due to its less advanced neural processing, with a maximum deviation of 5 millimeters in similar scenarios. Tesla's training methodology further distinguishes Optimus from Unitree. Optimus leverages a human imitation framework, analyzing 75,000 hours of human task videos, covering activities from assembly to cooking, to autonomously learn optimal actions. Elon Musk highlighted in a 2025 keynote, Optimus masters new skills in under 45 seconds by observing human behavior, a rate 600 times faster than Unitree G1's 30-minute training cycle for comparable tasks. This allows Optimus to adapt to diverse scenarios, such as handling packages of varying weights up to 55 pounds in logistics hubs, with a 99.9% success rate. Optimus Gen 3 self-correcting feedback system is another game-changer. Errors, like misgrasping an object, are corrected in 0.3 seconds, with the AI updating its model to boost future performance. After 15 million trial runs, this system achieves near-perfect accuracy, compared to Unitree G1's 90% success rate after 5 million trials due to its less robust feedback loop. For tasks like organizing shelves or assembling electronics, Optimus's precision is unmatched, while G1 excels in simpler locomotion but falters in high-dexterity applications. To ensure reliability, Tesla employs a stringent performance evaluation system, scoring tasks on accuracy with 0.4 millimeter deviation, and speed up 1.5 seconds per action, and energy efficiency 35% better than Gen 2. Only sequences scoring above 99.5% are deployed, unlike Unitree's 95% threshold, which allows for occasional errors. Optimus also prioritizes tasks intelligently, e.g. starting a 10-minute oven preheat before chopping vegetables with 0.8 millimeter precision, outperforming G1's linear task execution, which lacks such advanced planning. Optimus's over-the-air updates, inspired by Tesla's EVs, deliver 12 to 18 new skills weekly, enabling mastery of over 1,000 tasks annually, compared to Unitree G1's 200 tasks per year via manual updates. This ensures Optimus evolves rapidly without hardware changes, while G1 requires frequent firmware reconfigurations. Finally, Tesla's real-world data pipeline, collecting 150 terabytes daily from 7,500 deployed units. This data engine enables Optimus to handle edge cases, like navigating a 25-degree incline or manipulating irregular objects, with a 99.9% success rate compared to G1's 92% in similar conditions. So, how will the Unitree R1 compete with the Tesla Optimus? Simply put, the Unitree R1 is a lightweight humanoid robot introduced by Unitree Robotics in July 2025. But in reality, it's much more than that. While most humanoid robots on the market today are priced between $50,000 and $200,000, the R1 enters the scene with a starting price of just $5,900, significantly lower than the production cost of Tesla Optimus, which Elon Musk claimed to be around $10,000 in 2024. The Unitree R1 boasts 26 degrees of freedom, covering all movable joints in the body. Not just essential parts like the two hands, which are typically the focus in other robots with fewer degrees of freedom, such as the 12 to 18 commonly found in standard models. Although the R1 is clearly not yet ready to walk into your kitchen or home to perform over 3,000 tasks like the Tesla Optimus, a robot developed by Tesla capable of completing complex chores within 6 months of testing. The fact that a sub-$6,000 robot can move flexibly over rough terrain at a top speed of 3.3 meters per second, and even direct traffic in test scenarios, is awe-inspiring. What makes the R1 special? First of all, its ultra-light weight of only 50 pounds, much lighter than previous Unitree humanoid models like the G1 or H1. This makes the R1 not only easier to transport, but also safer and more flexible, requiring no specialized engineering team for handling, and posing minimal injury risk in collisions, with an impact force of only about 10 Newton meters at low speeds. For comparison, the Tesla Optimus can lift objects up to 40 pounds, enough to lift the Unitree R1 itself if needed. Beyond its physical capabilities, the Unitree R1 is equipped with a multimodal AI system that simultaneously processes voice and visual inputs, achieving up to 92% recognition accuracy in standard test environments. You can issue voice commands, and R1 not only understands but also analyzes its surroundings using 4 integrated 1080p cameras and a LiDAR sensor with a 10-meter scanning range. This robot features advanced functions such as object recognition with 95% accuracy for over 1,000 object types, facial tracking with a 0.5-second response time, and gesture detection with 90% accuracy under good lighting conditions. To give a clear example, if you command it to pour a glass of water, but there's no glass or faucet nearby, the R1 will use its spatial map stored in its 256 gigabyte internal memory to navigate to the appropriate location, such as the kitchen, at a maximum speed of 1.5 meters per second in confined spaces. In terms of power, the Unitree R1 can operate continuously for 1 hour using a 2,000 milliamp-hour battery, which can be swapped out in just 30 seconds. While this is 8 times less efficient than Tesla Optimus, which runs for 8 hours on a 16,000 milliamp-hour battery, the R1's quick battery replacement helps minimize downtime, especially valuable for researchers conducting continuous 3 to 4 hour testing sessions. The R1 is targeted at researchers, developers, and tech enthusiasts, not household assistants or warehouse robots. It is an ideal platform for testing bipedal movement with 98% step accuracy on flat terrain, AI interaction, and flexible control with its 26 degrees of freedom. At under $6,000, Unitree has lowered the barrier to entry for humanoid robotics, which traditionally required investments of $100,000 or more by labs or large corporations. This makes the R1 a breakthrough not just for its capabilities, but for democratizing access to cutting-edge technology for over 10,000 independent developers, driving faster innovation. You can take the R1 to makerspaces for customization, such as adding sensors or upgrading software, with estimated costs ranging from $500 to $2,000. R1 cannot carry loads over 11 pounds, lacks water resistance, has limited hand dexterity with only 70% grasp accuracy compared to 95% for the H1, and cannot perform complex actions like backflips or folding laundry, but that's not its purpose. More expensive models like the Unitree H1, priced at $90,000, are designed for those roles. R1 is focused on learning, experimentation, and development, serving as a research tool that moves like a human. At speeds up to 3.3 meters per second, understands its environment with 92% accuracy in test scenarios. How would Tesla offer Optimus for $10,000? Tesla has set a target to bring Optimus to market at a price below $10,000 by 2028, a revolutionary move aimed at breaking the cost barrier in the humanoid robotics industry. Currently, robots like the Unitree are priced at $5,900, but are limited to research purposes due to their capabilities, while high-end models like the Unitree R1 can cost up to $90,000, with a target price of $9,900. Tesla aims to make Optimus the first mass-market consumer humanoid robot, much like how the Tesla Model 3 democratized electric vehicles. Tesla plans to begin trial production of Optimus in 2026, with the goal of manufacturing 5,000 units at its Giga Texas factory. During this phase, Optimus will primarily be supplied to business partners, such as logistics and manufacturing companies, at a price of $15,000 per unit. These robots will be used to optimize production lines, for example, transporting components at speeds of 2 meters per second within factory spaces, reducing handling time by 30% compared to human labor. Tesla will also launch an Optimus beta program for 500 selected individual customers who are willing to pay $12,000 to test the robot and provide feedback, helping improve the hardware and software before the full public release. The final phase is set for 2028, when Tesla will officially launch Optimus for sale at a price of $9,900, targeting households, small businesses, and independent researchers. With a production goal of 100,000 units per year, Tesla will leverage its Gigafactory network in Texas, Shanghai, and Berlin to meet global demand. Optimus will be sold with an optional Optimus Care service package priced at $500 per year, which includes software updates, battery maintenance, and 24/7 technical support. Tesla will also release a mobile app that allows users to customize Optimus's tasks, for example, programming the robot to clean the house on a set schedule or assist in elderly care with 95% accuracy in tasks, such as timely medication delivery. Elon Musk's recent reveals and accompanying video showcasing Tesla's Optimus V3 humanoid robot operating in a real-world environment have ignited excitement in the tech community, particularly among enthusiasts and families eager for automation solutions in tasks like cooking, cleaning, and childcare. Unlike the simplified Optimus Gen 3, the V3 model represents a significant leap in household robotics, integrating advanced capabilities and the Grok voice assistant from xAI. This allows Optimus to personalize its voice, personality, and communication style, responding intelligently to users' emotions, behaviors, and gestures, such as navigating messy rooms or customizing hygiene routines. The robot's ability to learn from online videos enables it to perform diverse tasks, from taking out the trash to cooking meals, far surpassing the capabilities of other consumer robots. Optimus V3 builds on the impressive foundation of Gen 2.5, which captivated audiences with skills like dancing, boiling eggs, and expressive motions. The latest iteration can vacuum, stir food, interact with household appliances, fold clothes, water plants, pour drinks, check inventory, open car trunks, play with kids, and tidy kitchens, demonstrating its versatility as a multitasking companion. Musk envisions Optimus as a versatile companion, capable of tidying homes, watching children, mowing lawns, walking dogs, and potentially manufacturing goods or providing services. During Tesla's Q2 2025 earnings call, Musk confirmed plans to produce thousands of Optimus units by year-end, targeting 10,000 units with a long-term goal of 1 million robots annually within 4 to 5 years, signaling a bold push to make humanoid robots a global household staple. Musk has described Optimus V3 as an exquisite design with no significant flaws, emphasizing that it will feature a distinct design compared to the V2 robots currently used in Tesla factories. He stated during the Q2 2025 earnings call on July 23 that the V3 design is nearly finalized, with all necessary degrees of freedom, positioning it as potentially Tesla's biggest product ever, with a monthly production target of 100,000 units within 5 years. Musk also highlighted its integration with xAI's Grok 4, described as the smartest AI in the world, enabling advanced cognitive capabilities. He noted that Optimus could generate over $10 trillion in long-term revenue, potentially surpassing Tesla's vehicle business. Technologically, Optimus is evolving from a mere machine into a vibrant family member, helper, and friend. With a 52-volt, 2.3 kilowatt-hour battery from Generation 1 and a reduced weight of 125 pounds down from 138 pounds, it offers improved energy efficiency and can carry up to 45 pounds without performance loss. Its arms, with 22 degrees of freedom, enable precise tasks like threading a needle, operating tools, or preparing breakfast in seconds while cleaning up afterward. The robot learns continuously, becoming smarter with each use, and supports multiple languages for natural communication. Beyond chores, Optimus serves as a home tutor, reading books, assisting with homework, and providing information to the elderly. In healthcare, it aids with walking, eating, bathing, and managing conditions like Alzheimer's by tracking medications and key events. It also handles DIY tasks, such as changing light bulbs, fixing sockets, and alerting users to unusual incidents. Musk has projected that Optimus V3 prototypes will be ready by the end of 2025, with volume production starting in 2026 for external sales, potentially at a price around $20,000 to $30,000. He emphasized its potential to serve not only in homes, but also in factories, with initial low production for Tesla's internal use in 2025, handling tasks like battery management. Musk also announced that an Optimus robot will be sent to Mars in 2026 aboard a SpaceX Starship, showcasing its adaptability for extraterrestrial tasks. Additionally, he hinted at future integration with Neuralink, allowing users to potentially inhabit an Optimus robot for full-body control, expanding its applications beyond physical tasks. The integration of Grok and Tesla's mass production target for 2026 have sparked discussions on tech forums, with speculation that Optimus 5.3 could become a mainstream product. Unlike single-task robots, Optimus is designed for all-around performance in domestic settings, with Musk emphasizing its role in homes, not just factories. Its ability to operate via voice commands, gestures, or facial expressions makes it accessible, especially for users with communication challenges. Achieved in under 2 years, Optimus 5.3's capabilities, demonstrated through tasks like wiping tables, stirring pots, and vacuuming, mark it as a transformative step toward full automation, redefining daily life with unmatched efficiency and dexterity. When can consumers buy Tesla Optimus version 3? This question is receiving significant attention as Tesla continues to make remarkable progress with its humanoid robot. Elon Musk has announced that Tesla plans to produce thousands of Optimus units by the end of this year, with the ambitious goal of ramping up production to 1 million robots per year within 4 years. This ambition is well-founded, as it aligns with the rapid development of Optimus, from the initial prototype that could only walk to the second generation, which can dance, vacuum, and even boil eggs. Though still in development, Musk predicts Optimus could handle household tasks like a skilled assistant within 2 to 3 years. Unlike typical electronics, its software and algorithms receive near-daily updates, allowing rapid learning and adaptation. By mid-2025, over 100 Optimus robots are being tested in Tesla's factories, particularly at Giga Texas, with plans for real-world factory tasks by late 2025 and external sales possibly starting then. The upcoming Optimus Gen 3, set for a November reveal, will feature advanced hands with 22 degrees of freedom, 1.5x faster processing, and improved AI for greater autonomy. Mass production remains a hurdle. Musk emphasized that Optimus must be both functional and cost-effective to scale. Lessons from the Cybertruck's delayed production due to its complex design have led Tesla to simplify Gen 3 for manufacturability. Initially, Musk estimated a $20,000 price tag, but analysts suggest early units could cost $100,000 due to expensive components. However, Tesla's history of reducing Model 3 prices from $50,000 to $35,000 suggests future cost reductions for Optimus as production ramps up. Tesla envisions producing 1 to 2 billion Optimus robots, split between household and industrial use, such as assisting the elderly, caring for children, cooking, or handling repetitive and dangerous tasks in logistics, healthcare, and manufacturing. What do you think about this? Feel free to share your thoughts in the comments section below. We hope to bring the best information to you. Please give a thumbs up if you like this. Join Techno Creator by subscribing and hit the bell icon so you will not miss out on any awesome videos. We value your feedback. Thanks for watching. Until then, stay safe and have fun.